everyone. Myself, Dr. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, our session's topic is de-Broglie Hypothesis. So, the topics to be covered: de-Broglie Hypothesis, expression for de-Broglie wavelength, different expressions for the wavelength derivation, that is de-Broglie wavelength in terms of kinetic energy, de-Broglie wavelength for electrons, and then properties of matter waves. So these are the topics that we are going to cover in this session. First of all, what is de-Broglie hypothesis? De-Broglie hypothesis. De-Broglie extended the idea of dual nature of radiation to matter, assuming matter possesses wave as well as particle nature. De-Broglie extended the idea of dual nature of radiation to matter. So how he extended the idea of dual nature of radiation to matter is that matter possesses wave as well as particle nature. Matter possesses wave as well as particle nature. So the associated wave is known as de-Broglie matter wave. The associated wave. So what is the associated wave? What is the associated wave? A wave is associated with a particle. So particle and wave. So the associated wave is known as de-Broglie matter wave and its wavelength as de-Broglie wavelength. De-Broglie wavelength. So this is the de-Broglie hypothesis. This is the de-Broglie hypothesis. So whilst coming to this diagram, so here there is a wave. So in this wave, a particle is there. So where is this particle? So the particle is associated with wave. So in the wave, there is a wave which is having mass m. The particle having mass m is associated with this wave. So the particle have the velocity v and momentum while it is moving. And coming to the wave have a wavelength. So in this we are going to find the wavelength, de-Broglie wavelength. So the de-Broglie wavelength, which is for the matter wave, de-Broglie matter wave. That is, we are going to derive an expression for the wavelength of a wave associated with a particle. So here the wave is associated with a particle m having velocity v, and at the motion it gains a momentum. So we are going to find this wavelength of this matter wave. So expression for de-Broglie wavelength. So in this we are considering a photon having mass m. So photon having mass m and it is moving with velocity c. Then according to Planck's theory of radiation, the energy of the photon is E is equals to h nu. E is equals to h nu. As you know that nu is the frequency. H is Planck's constant. Where E is the energy of the photon. So here the frequency nu is equals to c by lambda. frequency nu is equals to c by lambda. So what is c? C is the velocity of light. C is velocity of light. Lambda is the wavelength. So substituting instead of nu, c by lambda. So E is equals to hc by lambda. So E is equals to h nu. So substituting instead of nu, c by lambda. So E is equals to hc by lambda. So taking as equation 1. So where c is the velocity here in the vacuum and lambda is the wavelength. So according to Einstein energy mass relation, E is equals to mc square. E is equals to mc square. So where E is the energy, m is the mass of the particle, c is the velocity of light. So from this 1 and 2, that is from the Planck's theory of radiation, E is equals to hc by lambda. And then the second one from the Einstein's energy mass relation, E is equals to mc square. We can write or equating that hc by lambda, where E is equals to hc by lambda according to the Planck's. And in the second Einstein's relation, mass energy relation, E is equals to mc square. So hc by lambda is equals to mc square. So from this, lambda is equals to hc by mc square. So where we can write hc by lambda is equals to mc square implies hc is equals to lambda mc square. So hc by mc square is equals to lambda. So that lambda is equals to hc by mc square. So we are translating lambda is equals to h by mc. So this we got here, lambda is equals to h by mc. So mc we can write velocity into mass, so momentum. So lambda is equals to h by p. So the momentum p is equals to mc. So this is associated with photon. So lambda is equals to h by p. If we consider the case of material particle of mass m moving with velocity v, then the wavelength associated with this particle is given by lambda is equals to h by mv is equal to h by p, where in the first case it is for the photon. It is for the photon. But we are applying this case to the particle. So that particle have the mass m and it is moving with velocity v. So the particle, a material particle we are taking and applying this case to this material particle. So instead of c, we substitute velocity of the particle v. So where in the first case lambda is equals to h by mc. So this is mass of the photon and this is mass or velocity of the photon. So this is regarding to the photon. But we are applying for the material particle. So while talking about the material particle, mass m and it has velocity v. So instead of mc, we are writing mv. So that lambda is equals to h by mv. So that is equals to h by p. So p is mass into velocity. So momentum. So h by p. So this equation is known as de-Broglie wave equation for wavelength of matter waves. So this equation is known as the de-Broglie wave equation for wavelength of matter waves. So different expressions for de-Broglie wavelength. So here we are going to see that de-Broglie wavelength in terms of kinetic energy and also de-Broglie wavelength of electrons. So first we see that de-Broglie wavelength in terms of kinetic energy. De-Broglie wavelength in terms of kinetic energy. So if E is the kinetic energy of the material particle, if E is the kinetic energy of the material particle, then E is equals to half mv square. So kinetic energy. So kinetic energy, as we know that Ke is equals to half mv square. But the kinetic energy taking as E. So E is equals to half mv square. So here half m square v square by m. So to write in terms of momentum, I am multiplying and dividing with mass m. So that half m v square into m by m. It is equals to half m square v square by m. Half m square v square by m. So instead of m square v square, can write as p square by m. So this can be written as p square by 2m, which we got here. So p square is equals to 2me. P square is equals to 2me. So from this is E is equals to P square by 2m. So what we got here, E is equals to P square by 2m. So from this 2me is equals to P square. So that's why here written as P square is equals to 2me. So P is equals to, then P is equals to, we can write root m 2me. So taking as equation 4 and then substituting the value of P. So what is P? The value of P in equation 3. So what is the equation 3? So that is de-Broglie wavelength equation. So wave equation. So that is lambda is equals to h by p. So this is the equation 3. This is equation 3. So substituting this p value in de-Broglie wave equation, lambda is equals to h by p. So can written as h by root of, what is p? Root of 2m e. So can get the equation 5 as lambda is equals to h by root of 2me. So this equation gives the de-Broglie wavelength in terms of kinetic energy. In terms of kinetic energy. So where the kinetic energy is involved in this equation, E. E is the kinetic energy here which we got. So de-Broglie wavelength in terms of kinetic energy. First we took that kinetic energy of the material particle E. So that is equals to half mv square, and then we write in terms of momentum, so that we multiplied with m and divide with m, so that we got E is equals to p square by 2m. So let's write p square is equals to 2me. From this, p is equals to root 2me. So this momentum substituted in de-Broglie wave equation, lambda is equals to h by p. So lambda is equals to h by root 2me. So this equation gives the de-Broglie wavelength in terms of kinetic energy. Next, coming to the de-Broglie wavelength of electrons. De-Broglie wavelength of electrons. So let us consider that an electron of mass m and charge E. So here, considering an electron, and that electron has the mass m, charge E, and it is accelerated through a potential difference of V volts. And this electron, which is having charge E, is accelerated through a potential difference V volts. So the energy acquired by the electron is E is equals to EV. E is equals to EV. And it is related to half mv square. So why I have written here E is equals to EV? Because the energy acquired by the electron, because of applying some potential difference V. So that is E is equals to EV. So electron having with charge E experiencing with potential difference V volts. Got it? That's why I've written here E is equals to EV. The energy acquired by the electron E is equals to charge of the electron E experience V volts of potential difference. So E is equals to EV, and it is related to half mv square. So half mv square is equals to EV. Or else we can write mv square is equals to 2EV. Here also multiplying with m square v square is equals to 2mev. Both sides we are multiplying. So mv square is equals to 2ev. So here I am multiplying mv square into m is equals to 2ev into m. So m square v square is equals to 2mev. So this we got here. And coming to the momentum, mv is equals to under root 2mev. 2mev. So this is the momentum. So let's substitute this momentum in the de-Broglie wavelength equation. So which is lambda is equals to h by p. De-Broglie wave equation, lambda is equals to h by p. So that lambda is equals to h by, what is this p? So mv. P is equals to, mv is nothing but p, momentum. So here the momentum of electron. So the momentum of electron P is equals to root of 2mev. So let's substitute instead of P, root of 2mev. So the de-Broglie wavelength associated with electrons is lambda is equals to h by root of 2m eV. So let's substitute the values of an electron. So what's the wavelength? What's the wavelength will become? So for an electron, as we know that charge of the electron is 1.602 into 10 power minus 19 coulombs, and mass of the electron is m is equals to 9.1 into 10 power minus 31 kilogram. And Planck's constant, we know that Planck's constant h is equals to 6.626 into 10 power minus 34 joule second. Substituting these values in the previous equation, which we got, lambda is equals to h by root 2m eV. So the equation 6 is lambda is equals to h by root 2m eV. So A is the charge of the electron, V is the potential difference which is applied on electron, and mass of the electron here, and h is the Planck's constant. Lambda is the wavelength of the electron which is associated with a wave. So lambda is equals to, instead of h, we substituted 6.626 into 10 power minus 34 divided by under root 2 into mass of the electron 9.1 into 10 power minus 31 kilogram, and the charge of the electron 1.602 into 10 power minus 19 coulombs, and V we don't know, so that we just write as V. So this, when we simplify this and calculated the values here, it is equal to 12.26 into 10 power minus 10 by under root V meters. So while writing in terms of angstroms, lambda is equals to 12.26 divided by root of V. So this is the equation which gives the de-Broglie wavelength of electrons. This equation gives the de-Broglie wavelength of electrons. So these are the topics that we covered here. And finally comes to the properties of matter waves. So here the de-Broglie wavelength which we got here is lambda is equals to h by mv. So that is equals to h by p. So from this relation we can easily write the properties. So the lighter the particle, the greater the wavelength associated with it. So if the particle is lighter, that is the mass is very less. If the mass is less, then lambda becomes greater value. So that is that here, the lighter the particle, the greater the wavelength associated with it. And lesser the velocity of the particle, longer the wavelength associated with it. If the velocity v, so v is less. If v is less, then lambda becomes high. Lambda becomes high value. So lesser the velocity of the particle, longer the wavelength associated with it. Next, coming to that third point, when v is equals to 0, that is velocity becomes 0 and lambda is equals to infinity. So what happens? And if v is infinity, lambda is equals to 0. So that is here v is equals to 0. V is equals to 0 in this case, lambda is equals to h by 0. So that it becomes lambda by h by 0. So it becomes infinity. So while in the case of V is equals to infinity, what happens? Lambda is equals to h by m into infinity. So that h by infinity becomes 0. Okay. So that here in this case, when V is equals to 0, lambda becomes infinity, and if V is equals to infinity, lambda becomes 0. So this shows that matter waves are generated by the motion of the particle. Due to the motion of the particle, these matter waves are generated. So matter waves are produced when the particles in motion are charged or may not be charged. Matter waves are produced when the particle in motion are charged or uncharged. Matter waves are not electromagnetic waves. Matter waves are not electromagnetic waves. They are pilot waves which are guiding the particle. Matter waves are not electromagnetic waves, and these waves are pilot wave which are guiding the particles. Matter waves travel faster than the velocity of light. Matter waves travel faster than the velocity of light. So these are the properties, some of the properties of the matter waves. So just have a look around the session's topic. So the topics that we covered here, de-Broglie hypothesis. So what is de-Broglie hypothesis? So de-Broglie extended the idea of dual nature of radiation. So how he extended the dual nature of radiation? By assuming matter possesses particle as well as wave nature. So the associated wave is known as de-Broglie matter wave, and its wavelength called as a de-Broglie wavelength. So this we called as a de-Broglie wavelength. So in this diagram, so a wave is there. So in this wave, a particle is associated. So that particle's mass is m, and it is moving with velocity v along with the wave. So while it is moving with having mass and velocity, it has momentum. Okay. So while we are talking about the wave, it has wavelength. So we are going to find the wavelength of the matter wave. So first we found that we derived an expression for the de-Broglie wavelength. So here we have to mind it. So here we are deriving wavelength expression for the matter wave. So matter wave means that a wave which is associated with a particle. So that we consider photon having mass and velocity c, and we took the Planck's quantum theory of radiation. So according to Planck's theory of radiation, E is equals to h nu, and here nu is c by lambda. So that it becomes E is equals to hc by lambda. So taking as equation 1, and then according to Einstein's mass energy relation, can return E is equals to mc square. So taking from equation 1 and 2, we correlated with both the equations. hc by lambda is equals to mc square. So from this we got lambda is equals to h by p. So this is for the photon. So the wavelength for the photon. So now we want particle. Wavelength for the particle which is associated with a wave. So that taking a material particle having mass m and velocity v, so that instead of velocity of light, we write velocity of the particle. So instead of c, we write here velocity of the particle v. So lambda is equals to h by mv. So that is equals to h by p. So this equation is known as de-Broglie wave equation, and for that is for the wavelength of matter waves. And coming to the de-Broglie wavelength, in terms of kinetic energy, we took kinetic energy as E. So kinetic energy E is equals to half mv square. So that half mv square we have written in terms of momentum. So half m square v square by m. So in terms of, to write in terms of momentum, just we multiplied and divide with m. So that we got p square by 2m. E is equals to p square by 2m. So p is equals to root of 2me. So let's substitute this momentum of the particle in de Broglie wave equation, that is lambda is equals to h by p. The wavelength equation becomes lambda is equals to h by root 2me. So this is the de Broglie wavelength in terms of kinetic energy. Next, coming to the de Broglie wavelength of electron. So here we are considering electron, so that electron mass is m and its charge is E, and it experiences some potential difference V, so that it gains some energy. So the electron gains some energy. So that energy is EV. So EV is equals to half mv square. So from this, mv is equals to root of 2m EV. So this we can write mv is nothing but P. mv is nothing but P. So P means momentum of the electron. So P is equals to root of 2m EV. Okay. So hence lambda becomes h by under root 2m EV. Next, substituting the values of electron, we can simplify lambda value. So that is a wavelength equation. So charge we know that, and mass and Planck's constant also we know. So that substituting these values in the previous equation, that is lambda is equals to h by root mev, which is for the de Broglie wavelength of electrons. So lambda is equals to h by root 2mev. So in that, substituting h, m and e values, charge of the electron. So in terms of meters, lambda is equals to 12.26 into 10 power minus 10 by root of v meters. In terms of angstroms, lambda is equals to 12.26 divided by root v. So this equation gives the de Broglie wavelength of electrons. So next, properties of matter waves. So by taking the de Broglie wave equation, lambda is equals to h by v, we can write the property. So lighter the particle, so greater the wavelength, and lesser the velocity, greater the longer the wavelength. And if v is equals to 0, lambda becomes infinity. If v becomes infinity, then lambda becomes 0. Lambda becomes 0. So this shows that matter waves are generated by the motion of the particle, and matter waves are produced when the particles in motion are charged or may not be charged. And matter waves are not electromagnetic waves, they are pilot waves which guides the particle. Matter waves travel faster than the velocity of light, that is c is equals to 3 into 10 power 8 meters per second. So above the range of this speed, the matter waves can travel. Okay, so matter waves travel faster than the velocity of 3 into 10 power 8 meters per second. So these are the topics that we covered here. So we shall meet in the next session with another topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.